drawing that you picked up out of the text and how we produce them?
It's like the most descriptive form of just like that object, how you can describe that object like with the most geometry and everything.
Yeah, maybe let me state it differently, Sean. If you were to create an oblique and you're using projection methods, what's unique about an oblique as opposed to these other drawing types we've already talked about? Gabe, you want to weigh in on that?
You're just kind of like looking at the front view, like the true like shape and size is what it looks like.
Yeah. Okay. In essence, that's it right there. There's one difference in it, and it's the reason it is there, and I'll get to that difference in just a second. I'll expand on what Gabe said, is that remember, obliques are really kind of used in the furniture industry. At least in my experience, that's the only place I've really seen them used. And we have a couple of those places around here that do use these. The front side is true size and shape, and then we recede the z-axis or the other axis. So we've got an XY axis that is true size and shape, and then our z-axis is receding, therefore it will not be true size and shape. But look at a piece of furniture like a kitchen cabinet. Where's all the detail at? It's on the front. Yeah, look at a desk. Where's all the detail at? At the front. On furniture, in essence, really, we've got that true size and shape front where people can build the doors, they can build the trim, they can put the flashing, all of that stuff on it, and then it's just a box after that for the most part. Now, they will revert when they build the box to an orthographic view, but that front view will give them what they need. You have a kitchen table, chair. Many times the spindles, the legs, the trim around them, it's all the same. If you can give them one view that's true size and shape of one part of it, then they just wrap it and they find out where it goes. So that's really what's unique. It's what they're trying to do with an oblique is actually make it a working drawing, pictorial in nature. That's what they're trying to do. There were three types. And these are basically used to remove distortion from it. Did anybody pick up the three types? What three types did we have? Lisa?
Triangular, cabinet, and general.
Okay. And what page are you on for that?
I don't know, I have my page now.
It's on 613.
Why would I do that?
Thank you, Andy. 614. Figure 1159. Okay. Here they are. Now, in essence, what you're really going to be looking at for the most part is what they call this cavalier, because it's the easiest to do. Everything's full scale except for those receding axes. Okay, so the front side is true size and shape. And now that's true on all these. If you look at this front view right here, it's the same in here, here, and here. It doesn't look the same due to some of the conventions they're pulling, but they are. And again, that's taking care of that front side. Now the cavalier is drawn much like an isometric, in that the receding axis is drawn full scale. You're still going to have lines that aren't parallel to those that are going to create a lot of distortion like a non-isometric line. So the cavalier, this is your main one right here. Okay, then you have a cabinet. Now the cabinet is strictly there because you get a lot of distortion when you're mixing true size and shape with receding axis as true size and shape. We get this huge distortion that goes on the back and it looks just funky. How's that for a technical term? It just doesn't look right. And so a lot of times they'll go to a cabinet where they take that receding scale and reduce it by half. Now this doesn't change anything other than it removes distortion from that view. Okay, that's it. If that one doesn't work real well, if you're kind of caught in the middle point on it, then they have the last one, which is general. Now here, they've stayed on here somewhere greater than half, less than full. Where do you think you'd probably do it?
3/4.
Probably 3/4. Yeah. Make it easy, right? Something that we know. And again, that's just for the display purposes, to make it look better. Because we're using the front to build. The rest is just to tie it all together in our mind. Yes?
Do squares usually use like the cabinet and rectangles usually use like the cavalier? if they're like a different form?
No, it's that receding axis is
Okay.
what's driving it all the way. You know, if you looked at something like this, okay, and if I chose this for my front view, I don't have much of a receding axis. I'm probably doing a cavalier, full scale. If I chose this as my front view, can't really hold on to anything. If I'm
Sorry.
choosing this as my front view, now I've got a heck of a receding axis in proportion to the rest of the object. I would probably immediately go to the second one, the cabinet, or if that one, I draw that one, if that one didn't work, then I would go to the general. Okay. Just to kind of get rid of that distortion, because this thing's going to look like it stretches on forever when you mesh it with that front view. Now, when you're doing these, again, you just set them up with your triangles, and then you got to do a little bit of math, and you're using your normal scales for it. The thing is, you don't have to pull that angle like they're showing here. These are all pulled generally at 45 degrees, but you don't have to. It depends on what you want to display. I really like this chart right here. It just kind of shows you, hey, you can take it whatever angle you want. If I need to see more of the top of it, like maybe I'm doing a kitchen table, then I'm going to choose something up in this round, because I see the top. If I need to see underneath the thing, then I'm going to choose something in here. If I don't really care, I'm just kind of trying to give them that third view, I'm probably going to go at 45. But keep in mind, all you're doing is drawing those guidelines and then measuring along them, making your lines and joining them together. Yes?
So if you do the bottom one, would you do like a section of the top, or what would you do to
Keep in
this
mind,
one?
these are generally used with orthographic projection.
Okay.
Okay, so this is one of maybe a series of drawings on an object.
Gotcha.
Depends on how complex it is.
Yeah, that's what I was gonna say.
Yes?
So question, so like in figure 11.6, they show, you know, a mechanical object showing the cavalier oblique and the cabinet oblique. They look completely different. So where is it mentioned? Where is it in your notes? How do you know what's the true? How do
Your
you build that?
dimensions.
If I tell you, how do I know which one to build?
It's a visualization thing. So you're looking at
Yeah.
this figure right here.
Yeah,
Yeah.
Okay?
so it's two different builds.
Right. And the only thing I can see on it is, if I drew this one, it looks like it's got a big nose, okay, Pinocchio here. I'm not really sure that, and you might have the physical part sitting in front of you, and you say, you know what, that really doesn't look like it. Then I'm going to start looking for different options. And so I can't really answer it all the way, Lisa, unless you had the physical part. Okay. Just watch out for those long axes. It's really kind of it.
Did you make a note in your drawing that says, hey, this is a cabinet oblique, or
Yeah,
this
you're
is
changing
No,
a
you don't.
scale?
You don't have to, no. You're going to work for an outfit that has it. This is not a standard drawing type. You're going to work for an outfit that has already trained their workforce in it.
Like I said, since it's furniture, the mechanical are typically aren't going to use these.
That's correct. Yeah. If I'm mechanical, I'm not really doing this stuff. Like I said, I've only seen one industry in my whole life that does this.
Okay.
Which brings me, on that question, I did ask about 2 conventions that you should follow when you're drawing these. That might aid you in helping make those decisions. What are those 2 conventions?
Object should be parallel to the frontal plane.
It's these 2 figures right here, right? And they kind of go along, it's 1, 2, 3. There's 2 things to do. And go back to that eraser I just held up. First thing, put your long axis parallel to your front view to get rid of that distortion that happens. That's the first convention. So if I'm picking something that's got a long axis, in proportion to the object, like this guy, this is going to be my front view. Because I know I'm not going to get a lot of distortion when I try and do this receding axis. That's my first choice. It's going to make this thing appear more like this versus here. So I'm sticking with cavalier as much as possible, and I'm using these 2 conventions first, and then I'll go to a different drawing type if it still doesn't work. So I'm going to stick with the cavalier, and I'm going to put my long axis parallel to the front view like they have here. This thing looks like, you know, what, cedar chest or something that a lot of you might have in your bedrooms. One year a student thought it looked like a casket, and I guess it kind of does. A
Oh.
little morbid thought, but you know, same concept. Sorry, and certainly a piece of furniture. This view right here doesn't have a lot of distortion because they put the front view right in the front, or excuse me, the long axis in the front view, as opposed to this one. You get a totally different picture with this guy. It looks skinny and long. It's not really. So that's the first convention. Put your long axis parallel to the front view. The second convention is right below it. And this one really aids us more than anything else. What happens when we take a cylinder and we turn it and rotate it? Turns elliptical, right?
Yeah.
Everybody's funnest thing. Missy, you love ellipses, right?
Oh, yeah.
And projecting them? I know you do. Well, with an oblique, we know everything on that front plane's true size and shape. So therefore, a cylinder projects as a circle. Put that type of geometry also in the front view. If you have to make a choice between the two, go with long axis parallel first, difficult geometry in the front view second. Then if neither of those work, then you go to the different drawing types, whether you go to a general or a cabinet versus your first try as a cavalier. Now you're going to have to probably work for somebody like Heritage or Smith Cabinets or something like that to get involved with these types of views. But there are drafters that do that. Certainly, you know, Franklin Building Supply has drafters that run their kitchen department. So does Home Depot, so does Lowe's. Those are all drafter people. So does Quality Trust. And they do these drawing types. Most of it's done in software, like 2020 or Build Cabinet or something like that.
Do they just like design them and then somebody builds them, or do they build them into mass production and then sell?
Both ways.
Both ways.
Yep.
That's cool.
Yeah, and it's a price tag issue, obviously.
Yeah.
You can spend a lot of money on a kitchen in a hurry.
Oh yeah.
All right, that's what I would like you to know as far as obliques are, is that you know how they're built, be able to recognize the different types, and the conventions used to help you draw the correct one. Any other questions on obliques? Then I asked you to look at some axonometric views. First off, we had 3 different types. I referenced this figure on the board yesterday.
What page is it?
580.
Correct.
You my glasses.
Figure 11.3, page 580. Can anybody tell me what the differences are between these 3 views? We have an iso, a die, and a tri. Yes, Lisa?
Angles, and axis, and how many are equal or not equal?
That's it. Angle that's going on this primary axis between our different, what would we call those? Planes,
Plane of projection.
principal planes, our X, Y, Z. So when I got a trimetric, what's going on with the angles on those principal planes?
There's no equal.
None of them are equal. Now, what that does is it removes distortion. This one's the most eye-pleasing. This one will look almost exactly how your eye sees it. So if you had a cube sitting on a table in front of you, this guy's going to look almost identical to it. But it's a great pictorial view. Now, the problem you get with the trimetric, since all of these angles are off, you have to build a scale for each plane. It's a proportional deal. We try and let software do that. So that's why I referenced SolidWorks the other day. When you get software and you go to the view bar, there is a trimetric button on a lot of this software. You just click it and then you can specify the angle you want in between those, and it generates it.
Thank God, so we don't have to calculate it.
No, I don't know anybody that does these by hand. It just takes too long
It does.
for the amount of distortion it removes. I mean, it's a great view because it's visually almost perfect. On the diametric, what's different about that one?
One angle's bigger than the others, isn't it?
Yeah, you have two equal angles, one angle it's off. That's why they got the die, meaning two angles are the same. Or two angles for the thing versus a tri which has three angles. Again, now here you'd have to build two different scales. Removes a lot of distortion, much easier to build. We get to the last one, ISO. I think ISO, isn't that a Latin word for one? Maybe it's Greek, I'm not sure. But we use it a lot of different places.
Oh, okay.
We have one angle between all principal planes. Therefore, we can use one scale. Why, I've mentioned it many times, 99% of all of our pictorial views are isometrics because of that. What is the angle on there? No,
No, it's
it's
not.
angle ABC. Remember, it's a full circle, 120. Now, how they get that is really, they're using orthographic projection to produce this. Remember, you'll have to do multi-views to do it, but the rotation angle to create an isometric is you take an object, you pick a front view. Let me go to the stuff that's got more detail. Okay, and then what we do is we take it and we rotate it 45 degrees, and then we tilt it 35 degrees, 16 minutes, or about 35¼ degrees. And this is shown in your text. That creates that 120-degree angle right here on your front principal axis. Where do they show that figure? It's on page 581, 11.5C. So keep in mind, when you're doing orthographic projection, that's what we're doing. We're taking it, we rotate it 45, and then we tilt it 35 degrees, 16 minutes.
It has to be exactly 16 minutes.
What's that?
It has to be 16 minutes.
Well, mathematically, yes, to get that 120 degrees, that's where it comes from. So it's not exactly, if you remember, there's 60 minutes and 1 degree, right? Remember that measurement system, degrees, minutes, seconds?
Yeah.
Well, 16 is about a quarter of that if you want to relate it to that method. There's two types of isometrics I asked you to look at. Did anybody find what those two were? This is the guy we're going to focus on. Oh, I turned it off. We're going to focus on isometrics because that's what we use. It's good for sketching. It's good for visualization. Has the most distortion, but not enough distortion to cause us to go to the other two viewing types. What are the two types? Lisa, you've answered a bunch. Let's somebody else have the word.
I read the.
Good job, Lisa. I'm proud of you.
Wait, what was the question?
There are two types of isometrics. What are they?
Could you explain it a little further?
No, not right at this point. I will in a minute.
Okay.
I'd like somebody to take the lead on it though.
A full-scale isometric drawing,
And,
an 80%.
or a true. And what figure are you looking at, Cheryl?
11.6.
Okay. They're shown right here on page 581. Now, you have the 80% isometric projection, which is really a true isometric. When you put that 120 degree item here and you've tilted it, it actually produces approximately an 80% proportional object. Now, again, you have to create a scale for that. Just like you would with a dimetric where you create 2 scales, a trimetric where you create 3. And it's trigonometry that allows you to produce these scales. The full scale is what we do. Why? Because we've already got a full scale, right? Our engineering, our architectural scales. Why would we take the time to do something else? This one's more eye-pleasing, this one's got a little more distortion, but you can do this one very quickly, and you can do it on grid paper. You can do it by hand. Many people are very good at them by hand. Doing a full-scale receding axis. Now, the one we use in industry, not this one, not unless you're using a grid paper set up to it, where they've taken that into account. Full scale is what we do. Yes?
So I was taught that we do the 80% just so it'd be more eye-pleasing, so it'd fit on the paper. So do companies care about that, or do we just stick completely to full size, just?
That would be a company decision, but if you're doing the 80%, it's not exactly 80%, it's like 79.9.
Yeah.
Then what you have to do is figure that proportion on that receding axis, and you gotta take every dimension of that object and times it by that number, and then lay it out along that scale at that number. And most companies I know, they're not gonna ask you to do that.
Okay.
Okay, because you're pulling out a calculator and every single line you make, I mean, you've got to say, okay, well, I know this is 4, and then I'm going to times it by 0.8, that's going to come up with what? That would be 3. And then I would measure off 3 and put it and then draw it. No, we'll just say, hey, you got your piece of grid paper, just count off 4 on the square and mark it off and go.
Go from it.
And it really, in my mind, it always comes back to, is there enough distortion between the two where you can't recognize it? Remember, this is really not a working drawing. It's a visualization drawing. Is there enough distortion to cause you to take that extra time and do it? In my mind, no.
Do you call, like I said, do you call it 80% projection and full scale drawing, like they do in there? You call one a projection, one a drawing? I mean, they call them different there.
Yeah, it depends on what I'm using them for, and I would communicate that in some form or fashion. Now, most people, they're just putting them, like, where you got an orthographic view and I got an isometric sitting in the top right to help them visualize. They're not going to use it. They're just looking at it and say, oh, that's what it's going to look like at the end. Now I can kind of mesh into this drawing, right? Yes?
Would you put in the notes if it's full scale, or would you not include it if it's already full scale?
Only if I was trying to build off of this thing.
Oh,
That's it.
okay.
And we're not going to be doing that a lot. That's why we use orthographic. That's our building drawings. But I want you to know that there are 2 different types. In case you ever come across them, you do need to know that. Now, I would guess, and there's probably some companies out there that do the trues. I've never seen one. Everybody's doing the full. Just because it's quick and easy. Does create more distortion. So what I'd like you to know as far as these types, you know these 3 types. Trimetric, all angles are different between the principal planes. Dimetric, you have 2 different angles between the principal planes, and you have 1 constant angle throughout. So all angles the same. Least distortion, middle ground, most distortion. Know the difference between the 2 isometrics, true and full. By the way, if you ever had to do one of these, you would see that on figure 11.7, here they're running the difference on the trig. You can create isometrics in any angle you wish, depending on what you're trying to display. And I would reference you to figure 11.9 on this. Keep in mind, if we're looking, want to see it show the bottom, you can go ahead and draw it in that view. If you want to see the top, whatever the case might be. You can rotate your isometric grid, but you have to rotate all of the angles if you wish. And that's what kind of what they're doing here and here. You can notice the distortion that occurs when you do that, though. Probably better not to. Any questions on what an isometric versus a non-isometric line are? Remember those? How do I draw a non-isometric line? So if you took figure 11.10 and you had to draw this, how would you know how to draw those non-isometric lines and get them as correct as possible? Because they're not to scale. They're not correct, but
Find the points where they end.
yeah, you have to find the endpoints. Because remember, you got full scale receding axes. Find those endpoints on your receding axis line. So I find that endpoint and that one, then I can draw the line.
What endpoints?
The endpoints of the line. So right there,
That one and that one.
right there. Because you can measure right along that line, right? You can measure up and over and find that point. I can measure over and find that point along that one. Remember, we start with a full cube, totally encompassing thing, and then we start removing items when we're drawing these.
Mhm.
Were there any other questions that you had with isometrics? Or, I guess I should say, with axonometrics, which is a classification of all three. Nothing? Okay. I do want to just remind you of one thing. I have mentioned this before, but I'm going to mention it again. Let's go to page 593. Cylinders on isometric planes. In AutoCAD, how do I get AutoCAD to draw an isometric ellipse? Does anybody remember?
You go ISO top, you go to the circle, and then you click ellipse.
You do what?
You go to ISO top in the corner or whatever. You click that, and then you draw. You go type in circle or ellipse, and then you click the opposite. I'm not sure.
You're kind of close. Let me rephrase the question. If I'm in CAD and I need to draw a cylinder on one of these planes, what is